Okay, so the lesson summary, um, hopefully we'll tie some of this together. Again, we're still dealing with functions. A sequence is what we're looking at. A sequence is an ordered list of terms. Often it is possible to write an equation to describe the sequence. A graph of the data can make it easier to see the pattern and decide if the data is linear or not. And in today's examples, we saw linear and exponential. The sequence below is formed by the square numbers. The formula for this sequence is f of n equals n squared. This is clearly not linear. This does not fall in y equals mx plus b. Um, Starting with n equals 1, that's important. We sort of made it clear that we kind of want to start with 1. And it gives you the examples of the subnotation versus the function notation. They mean the same thing. Normally, um, the subscript is what we would use for these lessons. For some reason, they felt that we could use the function notation so that you could get used to it a little bit. I think it might be confusing, but you guys are good. We'll get this figured out. They ask us then to take a look at the graph, which we see clearly is not a straight line. Looks exponential to us. Um, it's not always clear what is the next term in the sequence. Sometimes many possibilities exist when you have only the first few terms. That is true if you're just looking for patterns. Um, this is worth taking a look at and understanding that yes, there may be more than one possibility, um, but typically we can find some sort of pattern with what we're given. All right, in the end, we want to take a look at the terms. This is important. Sequence notation. The first term as a subscript is always going to be a sub 1. Um, the 100th term would then be a sub 100. It's supposed to be a 0. Okay. Um, any nth term would just simply be a sub n. The previous term is a sub n minus 1, and the next term is going to be a sub n plus 1. That's your subscript notation. Um, that is what is normally looked at. For our purposes, we're going to also look at function notation. Function notation would be f of 1. The 100th term would be f of 100. The any nth term would be f of n. The previous term would be f of n minus 1. Therefore, the next term would be f of n plus 1. This is important for you to see and know. Um, we can use these both in explicit and recursive forms. We'll spend some more time with recursive forms down the road.